You are welcome once again. What is the value of a? Given that you have 4 to the power of a plus 4 to the power of a equals 100, then let's have it to be solution. So this 4 to the power of a is common. Factor it out to be 4 to the power of a, 1.6. This divided by this will be 1, plus this divided by this will also be 1, equals 100. Then from here we have 4 to the power of a times 1 plus 1 in parentheses will give us 2, equals 100. Now let's do something with this. Dividing 2 by 2, so we're going to have this cancel out. We have 4 to the power of a equals 100 divided by 2 will give us 50. So from here, we can do something reasonable by introducing log to both sides. And the reason is that we have this to be in power. I mean, the value. The variable that we are looking for is in power a. So by introducing log to both sides of this expression, so we are going to have this power a in base. So from here, we have log 4 to the power of a equals log 50. Then from here, when we have, let's recall, when we have p to the power of m from the law of logarithm, this is what we call the base and the power. So we're going to have, so this is what we call the power. So we're going to have this power in base as m times log p. So definitely from here we have a times log 4 equals log 50. So from here too, we have this to be divided by what? By the coefficient of a, which is log 4. So this divided by this will give us a equals log 50 over log 4. Now, from here, let's simplify this further to have it in simplest form. Recall that we can have 50 as the product of 25 times 2. So by substituting it here, let's see what we're going to have. So what we're going to have will be a equals log, parentheses. You can say 2 times 25 over log 4. Now we have a. Then let us recall that anytime when you have log x times y, this always equals as when we have log x plus log y from the law of logarithm. So when you apply this here, we're going to have it to be log 2 plus log 25 over log 4. Then when you have parameter p plus m over n, such that this p, m, n, they are all members of positive integers. So we can have this as p over n plus m over n. So definitely a will be log 2 from here over log 4 plus from here log 25 over log 4. Then let's do something reasonable from here. We can have 4 as 2 to the power of 2. So here we have log 2 over log 2 to the power of 2. We can have 25 as 5 to the power of 2. So we can also have this as log 5 to the power of 2 over this log 2 to the power of 2. So we have it log 2 over. Applying the power law of log, we are going to have this to be 2 times log 2. Then this will be 2 times log 5 over. Look at this will be 2 times log 2. Now, from this, we have to cancel out this. We have log 2, cancel out this log 2. So definitely we have a from here to be 1 over 2 plus this will be log 5 over log 2. Then when you have log x over log y, from the law of logarithm equals as log x and base y. So applying it here, we are going to have a 1 over 2 plus log 5 and base 2. Log 5 and base 2. Now, the next thing for us is to check whether this problem will satisfy the problem given to us or not. So to check is very simple. We have to recall from the problem given to us, we have 4 to the power of a plus 4 to the power of a, we say equals 100. Given that the value of a equals 1 over 2 plus log 5 in base 2. When you plug in everything, so we're going to have, well, from here, one can have this back as, have it here. We can have this as 2 multiplied by 4 to the power of a equals 100. When you simplify, when you have this together, so we have 2 times 4 to the power of a 1 over 2 plus log 5 in base 2, then it's going to give us 100. That is the question. Let's have this 4 in base 2. So here will be 2 outside times 2 to the power of 2, open parenthesis 1 over 2 plus log 5 in base 2. Then it's going to give us 100. When this multiplied by this, you cancel out. So we have 2 times. Look at this. 2 to the power of 2 times this will be 2 multiplied by log 5 in base 2. Then, mind you,